So exactly how many geeks does it take to do a weather forecast? Welcome to What Is It About the Weather podcast, where we explore the many ways that weather intertwines itself into our lives. I'm your host, Mark Jelanic. And this week we're going to be kind of wrapping up our series on rethinking weather. And yes, we're going to get some geeky, nerdy things involved. You kind of had to know that with me, right? But before we get there, as always, hope you're having some good weather. Got a little bit of a heat spell going on for me this weekend. I can't complain too much. Earlier in the week, some cool temperatures, but really it was funny, kind of summer day. So first day is official of solstice-based summer, if you will. I had a day that was like, I don't know, fall or spring, but yeah, I knew that wasn't going to last. Just going to keep pushing through. Try to enjoy summer for what it brings and ignore it for the parts of it I don't like. Yeah, we all know what that is. We don't need me to dwell on that, so I'm not going to today. But it's also kind of spaghetti season. Yes. When I start talking about spaghetti season, that usually just means tropical cyclone season, for those that don't know. And why is it that we only talk about it with tropical cyclones and not other things? The reality is it's kind of spaghetti season all along if you look at the right thing. So for those of you that don't know, when we meteorologists talk spaghetti or spaghetti models, it's really just because it's a lot of different outcomes, a lot of potential outcomes based on kind of tweaking things at the beginning state, right? You can actually perturbate it different ways, but the general premise is let's mix things up a little bit, see if it has big outcomes versus little outcomes. And I tell people when they ask about how to interpret these things, and it's not that it's that complex, it's just there's no reason to add into our lives where we've got enough in our lives all the time, right? We don't need to add that into the mix. So what I tell people is if you look at something that someone calls spaghetti models, and if that plate looks like a bunch of goobly goo, truly like a bowl or a plate of spaghetti with it all over the place, that just means things are highly uncertain. If it looks like more like a box of spaghetti where everything's kind of laying out, right? Or, it doesn't have that much deviation in it, it just means it's saying it's a little more certain. That's the best way to think about it. That's the simplified answer I can give you for how to deal with a plate full of spaghetti, right? I guess, we always have to think about what type of noodles we're dealing with. This doesn't work with elbow pasta or bow tie or other things. That is why. But linguine would be a good substitute if you needed to be. Any case. I don't know if I mentioned the Yellowstone floods. I was caught by them because I was reminded, for those that, if you haven't been watching the news, there were some huge floods because of an atmospheric river situation, which we've discussed before, over the primary river that runs through Yellowstone National Park, and washed out some roads. They're calling it a 1 in 5. It depends who you ask. I saw a 1 in 500-year flood, 1 in 1,000-year flood. We're not going to get into the whole statistical definition, but it's a rare event. It's not a common event. In any case, it led to the complete closing of probably the most famous park in the U.S. It may not be the most amazing. Some people might argue that. I've been there. I think it's pretty amazing. It's an incredible amount of diversity that happens in Yellowstone. Incredible amount of wildlife, incredible amount of geographic features, and it's what's synonymous with the U.S. park system. And I said to someone, as this happened and as the park was closed, I said, this won't stand, right? You're going to find out very quickly money's going to get thrown at solving this problem. Because, one, it's actually a money-making part, I believe, for the National Park Service. They get enough visitors and enough people coming and going where it's probably one that more than helps cover the cost of a lot of other parks that just don't generate that kind of revenue. And first, there was this announcement that they were going to open the southern part of the park. So, again, if you don't know, it's kind of a figure eight, if you will. There's two loops. The southern loop's actually where the geysers, like Old Faithful, are. It's more famous. In any case, it was the northern part that had more weather damage. But I said there's a lot of motivation to fix this. And sure enough, this week it was announced that magically this park's going to be the vast majority is going to be open within a few weeks because they're going to dump a lot of money into fixing it. Now, I'm glad they're doing that, but it's a reminder of how well money works at solving problems. And, I get the same argument a lot of times. If you gave the National Weather Service, you can say that for any country, that kind of money, or if you put that kind of money into the models, you would get better weather forecasts. Yeah, it's all trade-offs. But we fall on the same thing a lot of times, right? That the forecasts most of the time are good enough. But I can tell you, if you had a catastrophic event where millions of people were hurt in a city, right? It's kind of like the thing we had in New York City here last year, and all of a sudden there was all this money spent on it. I always appreciate that happens. It's always sad that there has to be a negative outcome to get to a positive influence, but that's true of most things with human nature. We live in a crazy world, right? And there's lots of crazy stuff going on in the U.S. right now that we've been dealing with in the last couple of weeks. We've just come out of COVID. It's been a worldwide thing. But every day, right, we deal with this craziness. But as I sit here and deal with all this stuff and think about it, I'm also reminded that we're in the middle of a heat wave in parts of the U.S. And let's remember, we're in the season in the Northern Hemisphere particularly, right now, where heat is a real issue. And it's going to be a real issue for one area, then another, and so on as we go through these cycles. And I just want to remind you that this is a time to remember that heat kills, right? It can sneak up on people in a way that they don't appreciate because it's kind of slow. It sort of gets there, and then it's too late. So remember to check on people you care about. Make sure they're able to get access to sufficient means to stay relatively cool, well hydrated, well fed, and all those things. Take the time to care about somebody maybe you don't know. Go out and give somebody some water, some food, right, in this time. It's a tricky time. Heat is a bad, bad thing. Protect yourselves, protect the people you care about, but it never hurts to take care of a stranger as well. All right. Enough of me pontificating for a little bit. Let's get back into our final episode of Rethinking Weather. And we started with the ancients, right? And we went through some early thoughts about weather and tracking of weather. And then we went to Aristotle and his kind of cornerstone document that had some good ideas, but some flaws as well. And then we went into the Victorian age and really talked about, I guess, the coming age of meteorology as the industrial era was kind of kicking off. But today we're going to talk about what I call it the geek era, but we're going to call it the modern era. I'm going to hit the 1900s, and I'm going to stop and not do the last 20 years. Not because I don't think anything interesting has happened, but we cover so much of that in other things we talk about that I thought I would kind of cap it off. And what I'm going to do is I'm going to walk you through just an item or two. It's pretty much just one, but I know there were, maybe it's kind of hard to do, right? One episode per decade, if you will, or one's kind of summary idea per decade, if you will, that I thought was maybe the most important event that happened to help us better understand the weather or better be able to forecast the weather. That doesn't mean it's the only one by any means. And I was actually thinking about, as I was going through this, another podcast that could be done. I don't know that I've got the time or the energy for it, but it'd be really cool. And the idea of it's neat is just the history of weather, or the history of meteorology, maybe more than the history of weather, of taking some of these things that I've barely been able to talk about and really expanding upon it. And it would take forever. I remember listening to a podcast called The History of Rome. And if you've never listened to it, it's really good. And it gets into a lot of detail and things that I didn't know, but it provides so much more than you're ever going to get in a history class, and it's good kind of background. You don't have to overthink it. And yes, you could do something like that with meteorology, but I'm going to put a link in the show notes to something. It's the timeline of meteorology. It's in Wikipedia. And as with all things in the Wikipedia, I'm not trying to say that it's definitive, and I'm not trying to say that there's not potentially any errors in there, but I found it to be a useful resource in this sort of thing, and particularly in kind of helping me codify the choices that I made here. All right. So we're going to do each 10 years, one thing roughly, and then we're going to talk about where does that leave us today in terms of what do we get right and what do we get wrong. But before I do that, before I get into my list of things here, I want you to take just maybe one thing put one thing in your head. It could be more than one, doesn't have to be just one, of a reason you think we still get weather forecast wrong, right? Why? And it doesn't even necessarily have to be the forecast. One thing that is still prevalent that you've either heard or it could be why we still get forecasts wrong. And just set it aside in your mind. And again, don't feel like you have to do just one. I have some people I can think of that listen to the podcast that have probably already come up with 10 in the time I babbled about this. But let me go through my list, and then I'm going to talk to you about finalize the things that I think are still drivers into why we still get it wrong. All right. So let's start with the aughts. So 1900s. And this is the time that the primitive equations were first introduced. Now, I've referred to them in the past, but the best way to think about the primitive equations is a set of math. It's still math. It's a set of mathematical equations that very roughly represent behaviors in the atmosphere. All right. And anybody who's gotten a degree in meteorology of any kind will have seen these equations and may have to do some calculations around these equations, but they're just basically, they're what govern, if you will, a very simplistic model of the atmosphere and the weather we get, right? Now, they were kind of codified by an individual named Wilhelm Bjerknes, okay? And you may have never heard that name, but, I talked about Aristotle being the grandpappy of meteorology. Well, this person would probably be the grandpappy of modern meteorology, just because that was kind of the first step we took to recognizing that it's a scientific issue, right? And it's a mathematically based scientific issue. And much of what we deal with can be represented in these equations that sometimes can be made in a simplistic manner to help us do our forecasting. All right. So then we move into the tens, right? And very late in the tens, so that was in the early aughts, if you will, but very late in the tens, I think it was like 1919 or something along those lines, you actually got something called the Norwegian cyclonic model, right? And it's important to recognize this because you don't need to get hung up in the name, but this was the beginning of all the weather maps that we see with those little blue lines with arrows on them and little red lines with little humps on them and lows and highs and that sort of thing. But it was how we really began to visualize how weather kind of flows, if you will. And that was brought to us by Jacob Bjerknes. Yeah, same last name. Yes, related. Yes, son. But can you imagine having been in the first 20 years of the century and just these two guys from Norway had an incredible influence on how we think about the weather still today. It's pretty amazing. And like I said, that's why I said he was grandpappy and pappy, if you will. Again, these are just two people that at their time gave us some very important pieces into the equation, but it was kind of a defining moment of kicking things into a new direction in terms of whether maybe how we would still think about it today and still solve for it today that's really relevant. So then we moved into the 1920s. And I mentioned this in the last episode. There was a gentleman by the name of Lewis Fry Richardson. So you got to keep in mind this early 1900s. We were still kind of in the Victorian era, if you will. But this person was the first that did a weather forecast based truly on mathematical equations. And it would take him months to generate a one-day forecast. And the amazing part was the forecast was wrong. It was horrible. And there's good reasons for why it was horrible, but the premise was, could it be done? And what was the cost of doing it? And it just showed at the time that it wasn't realistic. Didn't mean it wasn't valid. Didn't mean there wasn't opportunity there. But it was proof that it could be done. Okay? Again, step in the right direction. So let's move to the 1930s. And the one I picked for the 30s was the Radiosonde. And for those that don't know, the Radiosonde is the thing that we attach to a weather balloon, as an example, that goes up through the atmosphere, and it relays information back to us about the vertical structure of weather. Now, this was done in Russia by Pavel, let me make sure I got I'm going to mess up his name, Molchanov is probably how it's pronounced, and I'm sure I got that wrong too. But that, to me, understanding how we thought about the atmosphere vertically and could do it at irregular intervals, and this is why we still have weather balloon launches around the globe today, even though there might be better methodologies of doing it. And I still do. I still think someday, using something that would probably be relevant for now, I still think we're going to have drones that go up in the air. We'll have fleets of drones because you can give you more coverage that go up at set intervals in appropriate places where they don't have, interfering air traffic, of course. But it's kind of like the same with a weather balloon that are going to give us the same sort of data. So I do think that that's kind of where the future of it is going. But we'll probably have something similar to that. Then 40s, I have to say radar, right? So radar was as much about, yes, identifying things during wartime, but we realized very quickly that it could tell you something about weather. And just think about how all of us today still, right? Even if you don't need to look at radar, and even if you don't necessarily know how to interpret radar, there's still, I think, if there's something that visually says weather more than those maps I was talking about, it is probably radar and seeing that. Okay. Then I think the 1950s, and specifically it was right at 1950, was truly the first computer models that ran the weather forecast. I can't think of anything or a moment in time that was probably more influential than that, okay? So it definitely had to be that. Now, you could argue, as I'm going through all these things, for different things. It was difficult to pick one, but, as an example, I've mentioned before the butterfly effect and the work that was done there, right? And I could have picked that, right? And I do think that that's important, but it's also important to recognize that some of those things came about because of these other things that we talk about. So the whole idea of chaos theory and Lorentz and that sort of thing, that kind of stuff was provided for by these other things. And that's why I say when I had to pick one, right, I picked a thing that was a place to start, right? This was a thing that meant a lot because as you look to the 60s, I had to make that choice. One would have been picking the butterfly effect, right? Or again, if I had to think about it, it was chaos theory, Lorentz, and that whole sort of thing that we've talked about. But of course, that was built on being able to compute those sort of things and solve those equations and see those nuances. So that is an option. But what I decided to go with instead was satellite. And yes, I know I'm a tech person. That's why I'm saying you could look at it either way. So from a scientific standpoint, the Lorentz thing was probably more meaningful in terms of maybe our understanding, maybe appreciating. Today, when I was talking about spaghetti models, that really is a feature of us understanding about chaos. But the reason I say satellite, it was the first time that we could grasp a view of weather over the entire Earth within a period of time. Now, the first satellites were all these polar orbiters, so they didn't see the whole Earth. But later in time, we would get these geostationary satellites that with a couple of satellites in the air, you could see the whole Earth almost instantaneously. Pretty amazing when you think about it, right? So that's what I chose. But again, it was a debate in my mind. So, if you wanted to pick a decade with a couple of them, I did that. And even when I get to the 70s, I did a couple as well. Because, and actually the first of these was in 1969, and the other one of these would have been in the 70s. So in 69, we actually got the introduction of the Saffir-Simpson hurricane scale. Now, Herbert Saffir and Robert Simpson those were the names they came from. The first one is an engineer. The second one was a meteorologist. But that gave us a way to codify some sort of reality around a hurricane to say at this stage, and you got to keep in mind that hurricane model was built on how structures would handle the wind specifically in a hurricane. Okay. And that's why the categories may not make sense and why they may break at odd numbers or intervals to you, right? And me even, because I don't know that I would define it the same way as a pure meteorologist, but it made sense for what they were doing at the time. And so it looked at whether this large scale event, and it gave us this methodology to codify it. On the flip side of that, right, Ted Fajita gave us the Fajita scale that we use for tornadoes. So here was this micro scale event, right? That again, we got a way to classify how strong it was, which was a measure really of how destructive it was. But I would say it was more in a meteorological sense. Okay. Any case, two ends of the spectrum, two ideas, but one fundamental premise, which is codifying measurements around events within weather as opposed to individual elements like what is the temperature, or like what is the wind speed, or like what is, how much rain is there. But at the same time, we need to keep in mind that it was an event, right? But it was still measuring elements. And this has been the argument with the Saffir-Simpson scale, is much of the destruction that comes with hurricanes or tropical cyclones isn't in the winds. Yes, winds can be damaging and they can do their thing, but the flooding and the rains and the storm surge and all that stuff is equally as important. And so there's consistently been talks about how do we revise and do new things in that regard. So that was the 70s. The 80s. I chose the Weather Channel. I know, you're thinking to yourself, how crazy. But really, this brought weather, unlike any source in the past, to the masses. Here it was, early days of cable television, and all of a sudden you could watch weather 24 hours a day. And that was a new thing, right? And it brought a collective audience to a single source of forecasts that had never occurred before. Amazing thing. And who would have known, I didn't know at the time, that the Weather Channel started just down the street from where I grew up. Now, I kind of learned this later. And now it's at a prominent location that's probably not, as the crow flies, no more than 4 or 5 miles from where I grew up as a kid. That said, it would be influential for many years. And yes, I know the Weather Channel, for many, it's not the same that it was. And, it started doing reality TV and maybe went in a direction that some of us don't like. But certainly with the demise of cable TV as we know it, it's had some of those challenges. We'll see where it goes with the streaming service. I saw that it's finally announced. Need to try that out. Maybe report back to you guys on it. So the 90s. What would have been for the 90s? Well, I chose the Weather Underground. And some of you may know them as a radical movement, but the Weather Underground, which formed at the same university as the Weather Underground radical movement did, was really the idea of bringing weather data, again, to the masses through the internet. And one of the founders, and again, I see different reports on who is credited with founding it, but probably the primary name is an individual by the name of Jeff Masters, who I've had the pleasure of meeting before. And it was really about bringing a way to take these sources of weather data and just make it available. It started out, bringing it to the classroom, but then it became about sharing it on the internet. And so as the internet was coming of age, so was one of the things that we all know and love, which was weather data. So those are the things I chose. Now, like I said, because I kind of pretty much chose just one, with the exception of the 50s maybe, the 60s, excuse me. The idea was just to capture something, right? Because there's so many things that I could go on for weeks upon months, and that's really not the goal of this podcast. But even with all that, even with the idea of these components, we don't always get the weather forecast right. And, why is that? So here's the things to kind of keep in mind as I see it today that limit our ability to perfectly forecast the weather, if you will. All right. Some is the science of the math. I talked about these equations. You got to keep in mind where computers are today, and this includes machine learning and artificial intelligence. At the end of the day, they're still using some sort of logic and or mathematics to derive a forecast. Well, those have to follow some sort of rules and basis, even if they're learning, right? And some of the science is just not well represented there. Sometimes this can be things like teeny tiny things like, how does a little piece of cloud form and how does that influence things, or little microclimates. But some of it can be larger scale. And I mean larger scale in the sense of it can be things that oscillate on our planet over the scale of hundreds of years that we don't fully understand because we don't have the data. All right. Now, the other is the connection, if you will, to the other systems of the Earth. It can be something like the ocean and the atmosphere, which we've made great strides in understanding connections. But just how, and because it's a hot topic now with climate change and everything else, how does the human behavior impact weather and those sort of things? And how do you represent that properly in forecasting and in modeling? But it can be things external to the planet as well. We understand a relative connection to the sun and sunspot behavior and those sort of things, but how well is that understood and how can we do things with it? Well, we don't fully know. And we don't always understand, time scales of impact as well. And, we learn things when we learn about, storms that are sent from the sun, right, in electromagnetic waves that can destruct other things, but do these things have impact on the weather in a way we don't understand, et cetera, right? So while we understand the basics, there's always an opportunity to learn more about these interconnected pieces that I think sometimes cannot be well represented in a weather forecasting tool like a model. So we've talked about this, if you will, this macro and micro, these ends, right? And that is part of the thing is we're trying to forecast something in the middle, whether it's for a certain geographic area or a certain time scale, that those macro and micro things don't always easily translate into. So just kind of keep that way of thinking in mind. But the last thing I think that we can't lose sight of is the whole idea of you can't put the toothpaste back in the tube. And when we talked about entropy, a couple months ago, and I used that analogy, right? But this has to do with just how we as humans think about weather and how incorrect information we were told, even if it was well-meaning, can lead to strange outcomes. And I'm going to give it a very recent example of this was a tornado that went through the city of Guangzhou in China, right? City of 10 million plus people. I don't know what the current population is. Huge city center. And it was a pretty destructive event. It's not the first one of these I've seen, though, right? People always say, and every time I see it, and I saw it then too, was I didn't think tornadoes could hit cities. And I'm like, that's just so not true, right? There was a tornado that went through Atlanta that damaged windows in a famous building in Atlanta, the Peachtree Plaza Hotel. And for years, you could kind of see the difference. I don't know if they fixed it because I haven't paid that much attention when gone through, but they were different color, and you could see which ones were shattered, right? And it had that kind of influence. But there had always been this thing that like tornadoes don't hit cities, or tornadoes can't go up and down over mountains, so we're safe here in a hilly area from a tornado. All just not true. Now, there was some logic maybe in someone's mind because they'd never experienced it, or someone, came up with a theory for why it was, and maybe because it was from a credible source or was from someone you loved or care about, you just took it as true, right? We do this a lot, right? With family members or with friends or with whatever. They say something, and because our natural instinct is to trust those individuals, we trust it. Not necessarily the best outcome. I think all those things, if I were going to do it right, because we've got this trying to squeeze everything out. We want our perfect micro forecast right for where we are, yet gridded models can't necessarily resolve all the, so we got this macro pull, right? We've got this how the models work, how they represent things. We've got all these things that are advancing stuff, but that doesn't make it perfect because we still got things like chaos, right? That you can't resolve for all these nuances things. Now, there are going to be ways to improve all those things, but the reality is for a while yet, it's not like you're ever going to get the perfect forecast all the time. And that's okay too, right? Because it provides an opportunity for learning. But I'm glad as someone who's a bit of a geek and nerd himself, that the geeks and nerds have got involved in trying to solve this problem with new approaches and new methodologies and new ideas. Okay. Doesn't mean we're going to be successful, but hopefully these approaches collectively can add more into our ability to make weather, right, something that is part of our lives without being a disruption in our lives whenever possible. Any case, right? The next time you pick up your phone or you look at a radar thing or whatever it is, whatever technology you're playing with today, the next time you're enjoying it, just remember there's much more to weather than the weather itself.